Welcome back. Welcome to level 2 of solving variable equations. Last time we looked at addition, where things are being added to the variable. Today we're going to look at things where equations where the variable is multiplied. So please make this the title on the next page in your math notebook. After you have done that, mark your page, unpause, and give me your concentration until we get to we do. All right, so let's look back. So remember, lots of things I want to remind you of since this is so new. So first, variables are usually like letters in an equation. So last time we looked at, say, I don't even need to draw you one. There's one on the screen already, right? So a variable is an unknown value in an equation. That's a variable right there. It represents a number we don't know and want to figure out. That's an equation because it has an equal sign in it. Remember, I mentioned briefly like expressions. That might be something like, that, where you can't figure out the variable. 10 plus m, what's m? I don't know. In an expression, you can't figure it out. But if you turn that into an equation, where there's something on the other side of the equal sign there, you could figure out that m equals 1. So that's the difference between an expression and an equation and a variable. So something like this we looked at last time in level 1, 17 plus y, or 17 plus what, equals 30. We looked at a common sense strategy where you could probably just look at that and figure it out. I showed you a drawing strategy where we put this side of the equation on one side of this balance. 17 added to y equals 30. And we wanted both of those sides to have the same amount on them, the 30 on both sides, and could use that to figure out that y equals 13. And I also taught you the inverse operation strategy, where we wrote the equation down, looked at the variable and said, well, what's happening to it? Said, okay, well, 17 is being added to it. The inverse of adding, the operation that does sort of the inverse of adding, is subtracting. So we subtracted 17. We did the inverse of what was happening to the variable on both sides. Very, very important. And that kind of told us y plus 17 minus 17. Those just make 0, so we can kind of ignore them. And all that's left on this side of the equation is y equals 13. So that was last time. Today, instead of adding to the variable, I want to multiply the variable. So to look at this. 4 times x equals 36. I want to talk about how to use the same strategies to solve this kind of equation today. So remember, our goal in any equation is to figure out the variable. That's what we're going to do. And just as a quick reminder, if you don't recognize this, you'll notice there's no multiplication sign. And I referred to this as 4 times x. We don't usually write multiplication with an x anymore because 4 times x would look like that. And that is super confusing looking. So we just don't write multiplication with that cross anymore. Different ways we might write it instead. Now that we use x as a variable a lot, you might write it like with a dot, as long as the dot's up high and doesn't look like a decimal, or you can just write nothing. So if you don't put anything between the 4 and the variable, that means 4 times x. So this is 4 times x equals 36. Let's use those same strategies to figure out x. First one, common sense, you can probably just figure it out. 4 times what equals 36. If you know your multiplication tables very well, you know that 4 times 9 is 36, and that's all it takes. Common sense may get you there with little to nothing else. Now, I'm going to still show you the other strategies because, like I said in level 1, eventually we're going to do ones, it won't even be very long before common sense will let you down, and it's just not enough. So I want to get you used to these other two strategies when the level is low so that as you advance, you're comfortable with them. So let's start with visual strategy. So what I draw now is going to be very different on my scale. So last time when we had like x plus 4, we drew x and we added 4 to it. But that's not how this is going to work. This is 4 times x, or 4 of x. So 4 times x looks like this. It's actually 4 different x's. 1, 2, 3, 4. So 4 times x looks like that. X 4 times, literally, the way we would say it. And 36 on this side. So what I want to do is I want this visual, this balance, this seesaw so to speak, to have the same amount on both sides. I want both sides to have 36. So I need to figure out what do all these x's have to be on this side so that I have 36 to match the other side. All the x's have to be the same. You know, it can't be 1 is 10 and 1 is 5 and 1 is 4. They're the same variable. So what does it have to be? And of course, to do that, they would each have to be 9 in order to have 36 on both sides. So x equals 9. Each x equals 9. So that's how the visual strategy works. Rather than adding a number, now 4 times x looks like that. Inverse operation. So I'm going to write out my equation. 4 times x equals 36. Separate my sides. And again, remember how the inverse operation strategy works. I look at the variable and I ask what is happening to it. So in this case, what's happening to x? It's being multiplied by 4. The inverse of multiplying by 4 is dividing by 4. So I'm going to divide both sides by 4 this time. Last time I subtracted, today I'm going to divide. 4 divided by 4 is 1. So the reason I did that is if I divide 4x by 4, I just get what 1x equals. And that's what I want to know. So again, these kind of undo or cancel each other out. That's why I do the inverse to begin with. Now I know what 1x will equal as long as I look here. 36 divided by 4 is 9, and I match the same thing I found. So last thing I always like to do is check to make sure. So 4x equals 36. What I'm going to do is called substitution to check it. Substitute what I think the answer is in for the x. So if I'm right, oops, 36, I just wrote the 3, sorry. If I'm right, 4 times 9 should equal 36, and it does, that's true, so my solution works. All right, let's do one in your math notebook. Take a pause here, write this out, write the name of the strategies out, and then we will work it out together. All right, 6 times x equals 78. Some things to know if you want to take a few notes here. Remember, in these variable equations, our goal is always to figure out x equals what? That's our goal. And another thing to remember is that this means 6 times x. You may not be used to that no symbol meaning times yet. That's 6 times x. You could also write that like this. 6 times x. Sometimes you'll see like parentheses too, like 6 times x could be written that way. There's just different ways we write out multiplication now because we don't want to use that cross because it looks like an x. So we need other ways to do that. So this means 6 times x. All right, first possibility is common sense. You might just be able to look at that and figure out what x equals. I don't know if you can or not. So I'm just going to put a question mark there. You never have to use the common sense strategy, but it is possible sometimes to just look and be able to figure out 6 times what is 78. I could probably figure that out if I wanted to. So I'm going to let you decide if you think you can figure that out with common sense or not. That's not a big deal to me because we're going to abandon the common sense strategy pretty soon because it rarely helps when we get more advanced. Drawing strategy, big help here. So draw your scale. So remember, I'm not going to draw this 6 now because it's not a number being added to x. It's how many x's I have. It's how many times I have this x. So the 6x side of the equation would look like this. 6 of the x 6 times, and 78 on the other side. So what I want to figure out, what does that x have to be for both sides to have 78 on it? Let's see, I'm going to sort of guess and check here. What about 10? If it was 10, I would have 60 on this side. That's too low. What about 11? I would have 66 on this side. Too low. 12. 6 times 12 is 72. Still too low, but I'm only away by 6, which means each x is 13. So if x was always 13, then both sides would have 78. And you may want to use a calculator. You may have another way to figure that out. The key is just to figure out what's each x have to be. If that doesn't help and you didn't like that strategy, I also always want you to know the other one. The inverse operation strategy is much mathier. and will lead you to the right answer every time if you do it right. So 6 times x equals 78. Cut down the middle. So what I do in the inverse operation strategy, I look at my variable and I look what's happening to it. What's happening to it, it is being multiplied by 6. So I will in turn divide by 6 because that's the inverse operation. Now, if I do it on this side, I also have to do it on this side. That's something to really get used to in algebra and dealing with variables. So 6 divided by 6 is 1. So that leaves me with just x, or 1x, so to speak, to see. And 78 divided by 6, I know it because I've already done it. You could use a calculator if you needed to. 78 divided by 6 is 13. And either way I do it, I get that x equals 13. Last thing to do, always a good habit to be in, is to check and make sure you're right. Check, we use a process called substitution. And it works like this. If 6 times x is supposed to equal 78, I substitute what I think the answer is in for the x and make sure my sides are equal. So I should find that 6 times 13 is 78. And of course I do. That's 78 and that's 78. Check. Smiley face. Yay. Way to go. All right. So now you've learned how to solve equations with multiplication in them by the variable and with addition in them by the variable. I bet you can imagine what two things are coming up next to finish out our beginning level equations. If this particular video didn't make much sense to you, please go back and give it another try before you do your You Do Together and You Do It Alone. But if you think you've got it and can use this example to do those, you're all set. See you next time.